I'm excited to talk to you all today about building secure software. I know it's an exciting and very sexy topic, security. But I would like to thank everybody again. This has been an amazing conference. I'm glad, Mason, that you bullied me to come. It's a really great community, and I'm really excited to be with you all. So thank you to the organizers, to the sponsors, and also to the Austin Central Library. If you haven't been to the roof deck yet, highly recommend it. So I just want to give you just a little bit of context, so where I'm coming from. Yeah, my name is Lisa. I am leading up developer education at ChainGuard. ChainGuard is a software supply chain security startup, and we're trying to make the supply chain secure by default. I'm also a maintainer on Sigstore, which is an open source project. We work across a few different organizations with academia as well to try to make security a kind of more of an invisible part of your software development practice. And I also wrote a couple of Python books, which are free to download and open access. And I am in semi-retirement as an academic. I am still teaching humanities PhD students how to code at Rutgers University. I'm not, lots of things. So you may be familiar with this. This is the gum wall at Pike Place Market in Seattle. Yeah, hooray, Seattle. So a lot of people like to bring their gum and stick it on the wall. But I don't think that many people like to pull gum off of that wall and then begin chewing it. I think most people would be concerned about the bacteria that they may find from some random piece of gum. But this is essentially what many people do with software packages. We're not validating where those software packages are coming from. We're installing dependencies that have dependencies underneath those, and we're just running that in our machine. I am also guilty of this. So if this is our approach, maybe we should be a little bit worried as developers and also as end users, because we don't know where the code is coming from. Vulnerabilities and attacks in software have been increasing in recent years. There's a number of government initiatives to have more policies around limited CVEs, or common vulnerabilities or exposure in software. There's increased awareness due in part to some high-profile attacks like SolarWinds, Log4Shell, CodeCov, Linux hypocrite commits, and there are also typo squatting attacks. These just exploit the software supply chain integrity all across the supply chain. So from your development, source code, the build, the packages, dependencies, production, all of those places are points where there could be a vulnerability or an exploit. This is not moving forward. There we go. So Sonatype estimates that software supply chain attacks are increasing exponentially year over year. This is a report that came out in 2022 before the year was complete. As developers working in the Python space, we need to think about the growing ecosystem around Python packages. For example, PyPI is growing faster than many other programming language package repositories. So these are some of the numbers from Python 2022. There's a 41% year over year growth and 176 billion packages. So here is an example of a recent high-profile attack in the Python ecosystem. This was PyTorch, and this impacted the PyTorch package at the end of 2022, right after, or right, I guess, in between the holidays at the end of the year. So we may think about software supply chain as a recent top concept, but when we think about security, a lot of these topics, a lot of the approaches to security are actually kind of from old industries and old practices. So if we think about just being out as a human in the world, maybe you want to open a new bank account, you go to the bank, when you get there, you ask, the teller is going to ask you for some ID before you could open up a bank account. So the bank is not the issuer of that ID. The ID probably came from a national or local governmental body, but your ID still attests to your identity, and the bank is going to accept this ID because there is a trust root that lies underneath that ID that goes to the ID issuing authority. So once you open your bank account, you will have a bank account number, which will be part of a database or a log, and that will be also connected to your identity. So when you use your bank account to make a deposit, or if you're making a debit against it, there is this background identity that is tied between these two, the number and your ID, yourself. And this ensures that money is coming in and out of the right place. With your bank account, you can get a bank card. You could either use a PIN or a signature to issue payment to others, and this signature also attests to your identity. Sigstore works in a really similar way. You bring your identity, your ID, a certificate authority, the governmental body that issued that ID, and a transparency log, in the analogy, the bank account database, together to enable verification and trust that to exist at each stage of the software supply chain. So some of the tools that are underneath Sigstore include Cosign, which is what we use to sign and verify software artifacts. A software artifact could be a container, it could be a README file, a binary, any of those are artifacts. And Cosign uses the OIDC to do keyless signatures, which is pretty cool. Fulcio is the free root certificate authority that binds public keys to emails with OpenID Connect tokens. So anybody can create a short-lived certificate instead of dealing with keys. If you want to, you could also use keys with Cosign. So Fulcio essentially is notarizing a particular login with a short-lived key pair. And then Rekor is that record. It stores records of the artifact metadata, and it provides transparency for signatures. You could think about Rekor as a bulletin board where people could post to that board, but nobody can ever take those posts off. But at the end of the day, you have to use your own judgment about whether you believe those posts on the bulletin board or not. Some other tools that are under Sigstore, which we're not going to go into that much depth, is Git sign, which allows you to keylessly sign Git commits, so you don't need GPG keys, which is pretty cool. And then there's also policy controller. If you're working with Kubernetes, this will enforce signatures or SBOMs or whatever you want to admit or not admit into your Kubernetes cluster. So this is kind of like a bigger architecture of how Sigstore works, but basically it's helping developers and end users alike through enabling identity, attestation, and verification over this root of trust. So what I was going to do a live demo, but the internet did not work for me at all yesterday, so we were going to do GIFs, but I linked out to this slide deck on my Twitter, which is Lisa Ironcutter on the bottom. And I also have the GitHub repo there, so please feel free to go there and check all this out. So this is a small Python script. If we run this code, we get the beautiful PyTexas logo printed onto our terminal. And what I'm going to do next is containerize this. So I'm not going to get into a lot of detail here in the interest of time, and because we're kind of more talking about Sigstore, but if you're interested in minimal container images, I suggest that you check out Wolfie and the undistro container images, which is how I'm going to build this container. I have links in the speaker notes to this, and Erica Heidi did a really great video overview, but it's essentially a tiny Linux distribution, and it's an undistro based on APK, and usually you're not running like a shell in here, basically. So what we're doing in this Docker file is we're using a development image as the builder, and this will have pip and the shell in it. And then we're taking that and building the undistro that comes without the shell and pip. And that just creates a lower surface area for potential attacks, making it a more secure image. Cool. And if you're interested in learning more about this, I have a tutorial online, which you could try and demo if you're interested. So right now, what this file system looks like is we have the Python script, we have the Docker file, we have that PyTexas PNG, and we have our requirements. And then what I did next, and this should still be live, is I pushed the image to ttl.sh, which is an ephemeral Docker image registry. And here we go. So this is the pushing, the building and pushing. And you could, this image, I put it up a little bit earlier, so you should still be able to pull it down. It's ttl.sh/pytexas:3h, and that just it makes it for 3 hours. Cool. If we wanted to, we could just pull it down and run it, so it'll show the PyTexas image again. Awesome. And then what we want to do next is keylessly sign the image. So Cosign, you could install it a few different ways. I installed it with Homebrew, but you could install it by source or however you would like. And what happens when you sign a software artifact, you run this cosign sign command, which creates a keyless signature. If you wanted to do keys, you would have to set up the keys, but this will go through the OpenID Connect flow, and then you could authenticate with Google, with GitHub, or with Microsoft. I'm sorry, it goes very fast, but it opens in a web browser, and you choose how you want to authenticate. So you could authenticate with GitHub. And you just verify that you're okay with this going on the transparency log. If instead you wanted to have everything be private, you could set up your own instance of Rekor instead. And then once you go through that flow and you sign in through Google, GitHub, whatever, then you get this nice page that says that the Sigstore authentication was successful. And then you get this T-log entry, which is in the Rekor public transparency log. It tells us our entry number and that the signature was pushed up to our container. So we could verify in a similar way. So with keyless signatures, you have to kind of know what you're looking for. So I had to put in my the email address and the OIDC, and then we get the certificate back, and we could check and make sure that everything looks good. So in practice, you might, you would just kind of verify that everything looks good between what the developer is saying when you check against it on the transparency log. And this is really cool, but this is the manual way, right? And we don't really like manual ways, so we do have GitHub Actions to make this kind of more part of your invisible infrastructure. You could kind of set it, forget it, and just keep having signatures being sent up to the image. We love to automate things. So then what happens is, I linked to this also in the Twitter. So this is the GitHub repo, and this is the GitHub action that has signing the container image at the bottom. And this is the keyless way. You could also sign this with keys if you want to instead. And when we run the action, we could check and make sure that that T-log entry is getting pushed to the signature. And then we could verify this the same way as an end user or as a developer that's leveraging this package. Cool. So this is very important, I think, to the Python community because PyPI is working to add more security features, including artifact signing through Sigstore. PyPI is not the only one. NPM is doing this work as well. And if you're interested in hearing more about the PyPI background information about Sigstore, Dustin Ingram gave a great talk at PyCon, and he's going to do another talk this coming PyCon 2. Did we have a question? I believe that Sigstore is in discussion with them, but I don't know the details offhand, but I could check for you. So PyPI has this dashboard to check and see the progress in the signatures being pushed to packages. And a lot of people are required to do two-factor. Many are opting in as well, even if they're not required to. If you're interested in learning more about Sigstore, there's a course that I co-created on the Linux Foundation, which is free. And very exciting news is that Sigstore will be participating in the Google season of Docs thanks to a grant from Google. So we'll be hiring a technical writer to help with the documentation to make sure that users can use it more easily. And we'll be posting information about applying for that. If you're interested in getting involved in Sigstore, it's a very active community. We have bi-weekly meetings, and there's the community repo that has information about joining the Slack. I find it to be a very welcoming and kind community that's, we're all kind of working to make sure that software security works better and is easier to implement. Oops, I don't have my image came over this, but thank you so much for having me. It's up to all of us to make open source more secure. So I'm happy to talk more with anybody here on the Discord or later on today about Sigstore, and I have stickers. Thank you so much.